Hey guys, just a quick review of the ocean basin. A lot of people have asked if I can put a video up showing what the basic features are of the ocean basin, so here it is. Remember that test is coming up soon, so knowing these features is going to be really important because we discussed these features during lab, we had them in lecture. These are things that you should absolutely know. Alright, so let's take a look at this diagram here, and I'm going to concentrate on this area right here, on areas 1 through 4. To be honest, part number 2, we didn't really talk about. They call that the continental break. We didn't really get there. But number 1, let's go ahead and take this area over here, and let's go ahead and zoom all the way down over here to the right, because this picture summarizes everything we're going to talk about. This part right here, this flatter part right here that's just under the oceans, this would be like number 1 in the diagram above. This is your continental shelf. Now the continental shelf is simply defined as the shallow extension of the continents that would be underwater. It's all continental crust, it's all shallow water, it's still under the oceans, and it's kind of where you start to make a transition from being in land to being into the ocean, but really you're not truly in the ocean yet. You're just kind of in that shallow transition zone. Now if we go back over here and we take a look at our diagram, we're going to take a look at number 3 now, this little area right here. And let's go ahead and zoom back in and concentrate on area number 3. Area number 3 is this part right here. This part right here is called the continental slope. Now the continental slope, this is a major transition zone from being in the continents to being in the oceans. This is where you're going to go from continental crust to oceanic crust. It's going to start to make a transition, and where that exactly happens depends on where, well, I'll be honest, which margin you're talking about. So in this diagram, I couldn't tell you where exactly the continental crust ends and where the oceanic crust begins, but the point is that this is a transition zone between them. And then if we take a look at a little more detail here, we have this continental rise. And I'll put that in a triangle. The continental rise is really where the ocean truly begins. This is where you're going to find all your basaltic rocks or all your oceanic rocks. This is also where sediment from the land is going to wash off the slope and go down into the ocean basin. I think in the book they talked about turbidity currents going ahead and doing that. Well, if we pan out from here and we take a look at our bigger diagram, number 4 right here, that would be your continental rise. Now the point is this, is that all of these put together, 1 through 4, this all makes up your continental margin. Where this guy here, number 1 is the shelf, number 3 would be the slope, and number 4 would be the rise. Make sure you have those notes down, and then we'll take a look at the rest of the ocean basin. Alright, so when we talk about the ocean basin, we're really talking about this whole part right here, this entire thing. The ocean basin is just a generic term from continental margin to continental margin and all the features in between. So this whole guy right here is an ocean basin, but the ocean basin has some features to it. Let's go ahead and take a look at some of the flattest parts of the features. Now people get this confused a lot. Number 5 right here and number 5 right here and number 5 right here are all the same thing. Those 3 number 5s are all abyssal, Y-S-S-A-L, plains, P-L-A-I-N-S. An abyssal plain, and like we talked about in class, abyssal plains are the flattest parts of the ocean. They're essentially featureless. They're not the deepest parts of the ocean, but they really have nothing going on. It's hard for life to really exist down there in great abundance because it's so deep within the ocean. Sunlight doesn't get down there very well, but there is still life down there. But the main point here is that these are really the flattest parts of the ocean. Alright, so let's talk about the deepest parts of the ocean. That would be number 7 right here. These guys here, this is the trench. The deep ocean trench. And the big thing about deep ocean trenches is they form from convergence. They form from a convergent boundary. And if we take a look and zoom in on this diagram down here on the left, we're going to see that at work. We talked about oceanic crust subducting underneath another piece of crust. And when that happens, we get this feature right here, this little divot or this pit, right where the 2 pieces of crust meets where the subduction's happening. This is where the trench will form. And at the trench, you'll commonly get earthquakes and stuff like that. We discussed about all that, the melting, the rising of the magma, the volcanoes either on the continents or within the oceans. But the big point here is that these trenches, these form the deepest parts of the ocean. So if we zoom back out and we take a look here, that's why we're looking at this. When we look at this diagram, this feature goes down lower than anything else. In fact, this is also where the lithosphere is the thinnest. The thinnest lithosphere is found at the oceanic trench. The thickest lithosphere would be found on the continents, on the mountains, but this is where the thinnest lithosphere is. Okay, so let's go ahead now and take a look at a couple of other features that you find along the ocean basin. One of them is this guy right here, number 9. Number 9 is a mid-oceanic ridge. And I know it's kind of hard to tell in this diagram, especially since I circled over it, but the top of this feature looks like this. And we talked about mid-oceanic ridges back when we talked about plate tectonics. We know that these are divergent boundaries. Where a trench is a convergent boundary, a mid-oceanic ridge is a divergent boundary. And this is where oceanic crust is spreading away from the volcano out towards the edges of the continents, and was a key piece of evidence that Harry Hammond Hess used to prove his idea of plate tectonics. All right, let's go ahead and take a look at number 8. Number 8 is a seamount. Now, it's hard to tell from this picture. It's either a seamount or it's a guyot. It's really hard to tell, but they're really similar. The only difference is this. Here we have a seamount, kind of a rounded or jagged, eroded mountain underneath the water. Then a guyot is very similar, except it's flat-topped. And an atoll is very similar to that, where you have a seamount or a guyot, and it's got a coral ring on top. And that's the big difference. So a seamount is somewhat rounded, and a guyot is essentially flat. And an atoll has that coral ring along the top. And that's the difference between the three. But the take-home message is this. These are all eroded features found on the basin of the ocean floor. And lastly, we have number 6 over here. Number 6 is simply an island. And it is a feature of an ocean basin. Why? Because it extends up from the ocean basin. It's not just a little piece of land floating out there in the middle of the ocean. Alright guys, so here's a complete snapshot. Number 1, the continental shelf. Number 3, the slope. Number 4, the rise. The 3 of those things make up the continental margin. All the number 5s are abyssal plains. Number 6 is an island. Number 7 is a trench. Number 8 would either be a seamount, a guyot, or an atoll, depending if it's rounded, flat, or if it has a coral ring. Number 9 is a mid-oceanic ridge. And over here we have another continental margin. We have the rise, the slope, and the shelf leading up into the continents. I hope you found this review helpful. If you have any questions, please feel free to send me a message on Edmodo or send me an email. One last quick note, trenches. Don't forget that trenches form from convergent boundaries and that mid-oceanic ridges form from divergent boundaries. And again, I hope you found this video helpful. If you have any questions, please feel free to ask me in class or send me a message on Edmodo.